Alright, here we go. We are going to do at least 11.1. I might be able to put 11.2 up tonight, maybe not. And we're going to be talking about radical expressions and rational exponents, and a connection between the two. And by the way, a rational exponent is just an exponent that has a fraction like that. That would be a rational exponent. And a radical expression would be, I don't know, something that looks like that. Right? So, and somehow these two are interchangeable, and our goal is to show that. Alright? So, if you remember that a number a is an nth root of a number a to the nth equals b. Alright? As you know, we indicated square roots with a symbol that looks like this, and a cube root with a symbol that looks like this. That means what root you're taking. Whenever you just see the radical sign, let's assume that there is a 2 there, even though we don't write it. In general, we indicate the nth root of a number as follows. That means we have a number, a, and we don't know what root. Could it be a square root? Yes. Could it be a cube root? Yes. Could it even be a higher root? Yes. Could be a third, a fourth, a fifth. All right. A rational exponent is an exponent that can be expressed as a fraction, like something like this: x to the 3/2 power, y to the 7/6 power, 5 to the 3/2 power. All right. The goal is we want n to be a natural number. If you remember, natural numbers have no zeros. There are no zeros, and that's the reason to make it a natural number. It doesn't really matter where the integers are. What's true is you cannot have a 0 in the denominator, ever. Especially in an exponent as well. Alright? So, the rule is you can have negatives in here, but no zeros on the bottom. Let's keep going. Alright. So, we see this, and we remember that the rule of a power is you multiply them together. So this is a to the m. That quantity to the nth power is the same as a to the m times n. Alright. Now, we're going to make a conjecture. Obviously, to solve this equation, right here, we took the square root of both sides, and what that did is that left me x to the first power. Alright, when I take the square root of x squared, I get x to the first. Alright. So can we solve that by using power of a power? So if I had something over here and I said x squared equals 4, very similar to this, is there something I can place as a power that would turn 2 into 1 like that? Well, hopefully you've guessed it. If I take it to the 1/2 power. Alright? So that would be it. Test your conjecture. We could with a calculator, but it works. 1/2 power of 2 is x to the first, right? And 1/2 power of 4 is positive negative 2 in that case. So if that was the case, how would I solve this? How would I solve x cubed equals 27? Well, truth is, I could take it to the 1/3 power. Alright? And this would give me x equals 3. Well, if that is the case, right? If that is the case, the square root of x, right here, must be the same as the 1/2 power of x. And the cube root of x must be the same as the 1/3 power, because they perform the same function. Alright? And what would be equivalent of the nth root of x to the first? Well, it would be x to the 1/nth power. So what you're going to notice is that the power goes on the top and the root goes on the bottom. And that's kind of a simple rule to carry you through this in case you ever get confused. Alright, what rational exponent would be this? Well, look at it, right? The power goes on top and the root goes on bottom. Same here, ready? The power goes on top and the root goes on bottom. There we have it. Nice and easy, right? I'm going to take a peek over here. I'm going to stop here. I'm going to call that page 1. And we'll continue after this.